Welcome to the deep dive. Today we're going right to the cutting edge, looking at the very latest in artificial intelligence. Our focus is the new Gemini 2.x family of AI models. We're digging into a pretty comprehensive technical report that just came out from the Gemini team at Google, dated June 17th, 2025. Our mission really is to pull out the key insights, maybe some surprising facts, just to help you get up to speed quickly on what makes these models a real step forward.
Yeah, this new generation, it's a significant step towards their vision of a universal AI assistant.
Hmm.
These Gemini 2.x models are really designed to push what the report calls the Pareto frontier of model capability versus cost, which, basically means they're aiming for the best possible performance for a given amount of computing power. Or looking at it the other way, the cheapest way to hit a certain performance level. It's all about maximizing that efficiency right at the edge.
Okay, that definitely sets an ambitious goal. So the report introduces this whole family, Gemini 2.5 Pro, 2.5 Flash, and then the earlier 2.0 Flash and Flash-Lite. What's the big idea behind this lineup?
Well, what's really interesting here is that the whole family seems fundamentally built to power what they call a new era of agentic systems.
Hmm.
Think of an agentic system like an AI that doesn't just answer a question, but can take a bigger goal, break it down, figure out the tools needed for each step, and, adjust if things go wrong. A bit like a project manager. And all these models are natively multimodal, handling different inputs like text, image, video all at once. Plus, they support these huge context inputs over 1 million tokens and have built-in tool use.
That sounds like a much more sophisticated way for an AI to tackle problems. So within that family, how do the different models stack up? What's each one best suited for?
Right, there's a clear sort of segmentation, Gemini 2.5 Pro, that's positioned as their most capable model yet.
Yeah.
It's hitting state-of-the-art on really tough coding and reasoning tasks. It's what they call a thinking model. Great at multimodal stuff, it can now process, get this, up to 3 hours of video. And it's this mixed long context, multimodality, strong reasoning that they think unlocks new kinds of agentic workflows.
3 hours of video. Wow. Okay, what about the others?
Then you've got Gemini 2.5 Flash. It still has excellent reasoning, but it uses way less compute and has lower latency. And it has this interesting controllable thinking budget. You can kind of dial in how much computational effort it spends. And then the earlier ones, 2.0 Flash and Flash-Lite, they're really built for speed and cost efficiency, more for everyday tasks or things you need to do at massive scale. They're more like the non-thinking models, prioritizing quick answers.
Okay, so it really covers a wide range of needs. The report also mentions improvements in safety.
Yes, that's a key point. The 2.5 models apparently keep those robust safety metrics, but they've also significantly improved helpfulness and kind of the general tone compared to the 1.5 and 2.0 versions. The goal seems to be providing safe answers without getting in the way of useful tasks or, sounding overly preachy.
Right. Now, I'm really curious about how they achieve this advanced reasoning. You mentioned these thinking models. The report talks about using tens of thousands of forward passes. Can you unpack that a bit? What does thinking actually mean here?
Yeah, it's a core idea for them. These thinking models use reinforcement learning, but specifically to use more compute when they're actually generating an answer at inference time. So imagine playing chess. Instead of just making the first decent move you see, you might simulate hundreds, maybe thousands of possible game sequences in your head first. These forward passes are kind of like that. It lets the model run through many internal possibilities, do more internal work, before settling on what it thinks is the best response. And this isn't just for some tasks, it's built in across all domains in the 2.5 thinking models.
That makes sense, like spending more time on harder problems. And the long context ability, especially for video, that really jumped out.
It really does. Gemini 2.5 builds on what 1.5 did with long context, but now it's apparently even better, still going up to 1 million tokens. I mean, that's enough context to feed it the entire novel, Moby Dick, or a whole software code base. And the video part 2.5 Pro going from 1 hour to 3 hours, that's a huge increase. It really changes what you can do in terms of understanding long-form video content.
So how does this translate into performance? What are the benchmarks showing, especially for things like coding or getting facts right?
Well, this is where you see some really big jumps, especially in coding. It's not just a small step up. We're talking about performance on benchmarks like Live Code Bench going from around 30% for 1.5 Pro up to 69% for 2.5 Pro. That's more than double.
Yeah.
And on Aider Polyglot, it went from under 17% to over 82%. Huge gains. It suggests these models are getting much better at complex real-world coding tasks.
Almost 5 times better on that second one. That's significant.
It is, and for factuality, the 2.0 and 2.5 models can natively use tools like Google Search. Gemini 2.5 goes a step further by weaving that search capability into its reasoning process, letting it tackle more complex questions that might need multiple lookups or steps.
Okay, so understanding and reasoning are clearly enhanced. What about generating content? I saw mentions of new audio and video generation capabilities.
That's right. Gemini 2.5 was specifically trained for audio tasks, things like text-to-speech or even generating dialogue based on audio-visual input. The TTS, for example, supports over 80 languages, and you can control the style, emotion, pace. It can even do multiple speakers. They mention using it in Notebook LM audio overviews. And for video, some new applications mentioned are things like creating interactive quizzes from video content, or even generating simple animations like p5.js animations based on watching a demonstration video.
Generating quizzes from video. That's interesting. Now, one of the most maybe fun parts of the report is seeing this stuff in action. The Gemini Plays Pokemon experiment. Tell us about that.
Right. This is a fascinating demonstration of these agentic capabilities we talked about. An independent developer basically set up a Twitch stream where Gemini 2.5 Pro played the original Pokemon Blue game all by itself, autonomously. The first time, it took about 813 hours to beat the game. Then they ran it again, fully autonomous, and it managed it in 406.5 hours, half the time.
Wow.
And this wasn't just simple button pressing. It had to figure out complex puzzles in the game spinner tiles, the Safari Zone maps, navigating long routes, those tricky boulder puzzles. It really showed off that long context planning and tool use.
Beating Pokemon Blue autonomously? That's pretty impressive for an AI. Did anything particularly surprising come out of that experiment?
Actually, yes. One really interesting detail is that the agent apparently found a new bug in the original Pokemon Red-Blue game code while navigating the Seafoam Islands dungeon. The developers think this specific bug hadn't been found by an AI before.
A novel bug discovery.
Yeah, it kind of highlights that the model isn't just following instructions, it's interacting with the environment in complex, sometimes unexpected ways.
That's quite something. But it wasn't perfect, right? Were there limitations observed during the Pokemon run?
Definitely. While it was good with the text-based information about the game state, the report notes Gemini 2.5 Pro struggled to directly use the raw pixels from the Game Boy screen. That visual info needed to be translated into text first. And another point, even with that huge million-token context window, for the kind of generative reasoning needed in these agent setups, they found that once the context got beyond about 100,000 tokens, the agent started to sort of repeat old actions from its history instead of coming up with new plans.
A kind of looping behavior.
Exactly. They call it a looping issue and mention it's something they're actively researching.
Okay, so Pokemon is a great showcase. But what about other, maybe more practical or creative uses for Gemini 2.5 Pro?
Well, the report highlights its strength in taking diverse, messy inputs and turning them into something useful or interactive, like generating a tool for drama students to practice lines just from a PDF script, or creating a book recommendation app based purely on a photo of your bookshelf.
From just a photo.
Apparently so. It can also do things like convert images into structured formats like HTML or SVG code, and the 2.5 Pro version is noted as being much better at capturing visual details accurately compared to older versions, and can generate fairly sophisticated simulations or visualizations, interactive models of the solar system, renderings of abstract math concepts, things like that.
And you mentioned earlier these models are already finding their way into products we might use.
That's right. The report explicitly states Gemini models are part of various Google products. Things like AI overviews and search, Project Astra, which is that audio-visual dialogue agent, Gemini Deep Research for researchers, Notebook LM's audio features, Project Mariner for web browsing, and even Google's coding agent, Jules. So it's not just research, it's being deployed.
Which brings us to the crucial topic of safety and responsibility. With models this capable, how is Google approaching that, according to the report?
They emphasize a strong commitment there. The report lays out clear safety policies against harmful content. The standard categories like CSAM, hate speech, dangerous instructions, and this applies across all modalities, not just text. They also define what they mean by helpfulness, basically. Try to fulfill the user's request, assume good intent, and only refuse when truly necessary, without being judgmental.
And how do they actually bake that safety into the models? What's the process?
It's a multi-layered approach. Starts with filtering data sets used for training to remove harmful content. Then monitoring during pre-training using supervised fine-tuning with deliberately challenging or adversarial prompts involving human review, and then also using reinforcement learning from human feedback and, interestingly, critic feedback as well. And for the 2.5 models, they specifically highlight improving helpfulness and reducing those over-refusals times the AI says no when it shouldn't compared to 2.0, while keeping safety levels high.
You also mentioned automated red teaming. What exactly is that?
Right. Automated red teaming, or RT, it's described as a kind of multi-agent game. You have attacker AI models that are specifically designed to try and trick the target Gemini model into giving unsafe or unhelpful responses. It allows them to find and fix potential problems much faster than just relying on human testers, generating thousands of test examples per hour. And the report shows data from RT indicating that it helped significantly reduce helpfulness violations for both 2.5 Flash and Pro.
Okay, that's internal testing. What about external threats, like security vulnerabilities? The report mentions indirect prompt injection. How do the models hold up?
They tested for that. Scenarios where malicious instructions are hidden inside external data, like a web page or a document, the AI is asked to process trying to manipulate Gemini into doing something unauthorized, like leaking private info. The results showed Gemini 2.5 Flash and Pro are more resilient to these attacks compared to older versions, thanks to new security-focused adversarial training. Though, interestingly, they do note that in these specific tests, the Pro model was slightly less resilient than the Flash version.
And what about privacy? The concern that these large models might just memorize and spit out training data, including personal information.
That's a key area. The report states the Gemini 2.x family memorizes long-form text at significantly lower rates than previous models. And critically, they state that for the 2.x models, quote, no personal information was observed in any outputs classified as memorization. They do acknowledge that some specific divergence attacks can still force some memorization, maybe around 0.2%, but it tends to be things like common code snippets or public web content, not PII.
Okay, and finally, they discuss evaluations against their frontier safety framework, assessing really high-stakes risks like misuse for chemical, biological weapons, or major cyber attacks. What do they find for Gemini 2.5 Pro?
All right, Google DeepMind evaluated 2.5 Pro against these critical capability levels, or CCLs, for serious potential misuse, CBRN, cybersecurity, accelerating dangerous AI research, things like that. The key finding, as of the report date, June 17, 2025, is that Gemini 2.5 Pro does not reach any of these critical capability levels. They did note an alert threshold was hit for one specific measure related to cybersecurity uplift, suggesting potential future capability there. And they say mitigations are being accelerated. But overall, their internal and external safety tests concluded the models, as they are now, aren't capable of causing catastrophic harm on their own.
Well, we have certainly covered a lot today. We've unpacked the different models in the Gemini 2.x family, looked at those really impressive performance gains, especially in coding and handling long context like video. We explored the emerging agentic side through that fascinating Pokemon experiment and touched on the wide range of applications. And importantly, we heard about the extensive safety, security, and responsibility measures being implemented.
It's definitely a lot to take in. The kind of advancements highlighted here, processing those 3-hour videos, the autonomous gameplay, it really underscores just how fast AI is moving.
It really does. And that brings us to a final thought for you, our listener, to ponder. As these AI capabilities continue to accelerate at such a frankly, extraordinary rate, how do we as a society need to evolve our own ways of evaluating these systems? How do we ensure that our benchmarks, our safety checks, our understanding truly keep pace with what these AIs can actually do, making sure we're measuring things that reflect their real-world potential and challenges?